Good morning. I'm going to do a short lesson on what we went over yesterday or 2 days ago on the board about the trophic levels, just so that you understand a little bit better what's going to be expected of you on the test. So in your pyramid, which we're going to go over today, it is set up in such a way that the trophic levels belong in each one of these lines. The first trophic level are your autotrophs, and those are the organisms that make their own food. Anything that performs photosynthesis. So in the first trophic level, right here, you can pause the video, you need to write the word autotroph, and these are your plants. But plants are not the only organisms that undergo photosynthesis and make their own food. There's also algae, and algae are protists. So we're going to talk about classification later. You had it last year, but there are two kingdoms that have organisms that undergo photosynthesis. That's the plant kingdom and the protist kingdom. Plants and algae. And that's what you need to write right here in the first level. I'm not going to stop the video. I'm just going to keep on going. So autotrophs, this is photosynthesis, and they get their energy from the sun. So the organisms that are here, these are your producers. The producers are the ones that actually get energy from the sun and turn it into carbohydrates or sugars. Okay, so that's what you should write there. Actually, I will write that. So those are your producers. Okay, and they get their energy from the sun. Okay, and they are right there. So it says producers, they get their energy from the sun through photosynthesis and actually change it into chemical potential energy. So we now have a light energy being changed into chemical energy, and you should be writing all that down. Just pause the video. So that's what an autotroph does. It takes light energy and converts it into chemical energy in the form of sugar. And that is done through the process called photosynthesis, and it's done by plants and algae. Okay, so next level up, you have your primary consumers. And the primary consumers nothing can make its own food after that. So anything that has to eat another organism to get energy is called a heterotroph. That means other. Hetero means other. So your heterotrophs belong here. And they are the primary consumers, primary meaning first, they are the first consumers, and they eat the producers. The only way that these consumers, anything above on the top of the pyramid, can get energy from the sun, because this is ultimately where it comes from, is they have to eat something that converted that sun into sugar. And that's what the primary consumers do. So we're going to write primary there, primary consumer. You're going to stop the video, and you're going to write primary consumer. And you're going to write heterotroph, and that's what's here. You should also be able to put an example of a heterotroph or a primary consumer, like a rabbit, okay? After that, we're going to go up to the next trophic level. These are the organisms that would eat the primary consumer. These are your secondary consumers. You can put whatever you want to there as an example. These are also heterotrophs. They do not make their own food. They have to eat something that has already converted it to chemical form so that they can eat the chemical form of the sun, basically, is what you're doing. So these are your foxes, maybe a wolf, maybe a dog, something that would eat the rabbit, the squirrel, something that would be a primary consumer. That's your secondary consumer. All right, so after that, at the top here, you're going to have your tertiary consumer. Tertiary starts with a T, so it is third. So it's your third consumer. And, of course, that's going to be something that eats your fox or whatever. So you might have your boa constrictor, maybe a lion, something like that at the very top. And these tend to be what we call our apex predators. Nothing really eats them. They are at the top of the food pyramid, if you will. And that's what would belong up here. These are your tertiary, consumers. All right, these are also heterotrophs. So stop the video if you need to, because I'm not going to write it in there, and figure out how to write tertiary consumer. All right, now we're going to look at the energy. We're going to look at why. We're going to explore why this is actually shaped like a pyramid. So down at the bottom, all right, we're going to say we have 100% energy, which isn't really true. But these producers take the sun's energy and they turn it into chemical energy. So we're going to say there's 100% down here, or 1. We're going to put the number 1 next to it. All right, so one whole thing, one whole unit of energy, if you will, 100%. Now, as the primary consumer eats the producer, so as the rabbit eats the plant, all right, and I have my little plant here. So if I had a rabbit that ate this entire plant, okay, this entire primary consumer, and got all of the carbohydrates out of it to sugar, how much of this plant could that rabbit actually use? Can it use 100% of the energy that is in this plant? Can it use 50% of the energy that's in this plant? How much of this chemical energy that's in this plant can the rabbit actually use for its own energy? Do you know? Okay, it turns out that it is 10%. Only 10% of the energy, even if the rabbit eats the entire plant, only 10% of the energy that's actually in the plant can actually be used by the rabbit. So we're going to write 10% next to the primary consumer. All right, so 10% of the, can be used 10%. That's all that goes into the rabbit or the primary consumer. Okay, so if 10% is used, then that means how much is not used? 90%, that's right. So what happens to the other 90% of the energy if it's not used by the primary consumer? What happened to it? Energy is neither created nor destroyed. It only changes form. So it went somewhere. It was not destroyed, didn't just disappear. You have to always ask yourself, where did the energy come from? So we did that. Energy for the producers came from the sun. The energy for the primary consumer, for the rabbit, came from the producers. Well, what happened to make them function, hop around, think, and all that? The other 90%. Okay, it gets wasted as heat. So 90% and waste. So it's waste and heat, or thermal energy. Okay, so 90% just leaves as heat, thermal energy, and a little bit of that is waste, okay, what the rabbit doesn't use. Okay, so as the secondary consumer eats the primary consumer, how much of the energy that's in that primary consumer do you think the secondary consumer, the wolf, the fox, can use? 10%, that's right. So it turns out that's 10% as well. So that means that 90% is wasted as heat. So now we only have 10% of the 10% that went into that fox. We're going to go all the way up to the polar bear, to the lion, or to the, whatever this top tertiary predator is that ate the fox. How much energy do you think gets transferred to them from the fox? 10%. So we're going to write 10% again. And 90% is wasted as heat. Okay, you're going to put a little energy is left, leaves as heat, write the word heat there, and waste, heat and waste, okay? All right, so on the other side, we're going to write 1. So if we have 1 unit of energy here in our producer, what is 10% of 1? It's a decimal, right? So it looks like this. Okay, so our primary consumers only get 10% of what was in the producer. If the secondary consumers only get 10% of that, then that looks like this. That's a 1/100th, okay? So the secondary consumers are only getting 1/100th of the amount of energy that was in that original producer. And if we go up to the very top, to the tertiary consumers, they only get 10% of the secondary, so that's 1/1000th. Okay, so as you're moving up, when you get up here to the top, there's only 1/1000th of the amount of energy that was available down here at the producer level is available to these top apex predators, these tertiary predators. That's why this is shaped like a pyramid. Notice that each of these levels gets smaller and smaller because there's less and less energy available to be used as you move up, as you become a different predator. So up here at the top, that's why there are fewer wolves, not wolves, but lions, polar bears. There are fewer of them on the planet just because there's less energy available for them to sustain them. Down here, there are many, many more producers because they can use, there's much more energy available to them from the sun that can be used. There are more primary consumers than there are tertiary consumers because the primary consumers have access, they can use 1/10 of the energy. There's just more energy available for them than there is as you move up this pyramid. So there's many, many fewer of these organisms than as you down here. And that's what you see on the planet. There's very few of these top predators up here. And so that's how the pyramid works, the trophic levels. That's why it's shaped like a pyramid, gets smaller on the top. It's energy. It's showing you how energy flows in an ecosystem. So we're going to actually write that at the top. We're going to write energy, flow, and an ecosystem. And an ecosystem, all right, is living systems. So every single organism on the planet, every living thing is going to fit someplace in this. And then, of course, we have our decomposers, and they're at the very top, and but they're a little different there, that we don't really put them in here. Okay, so I hope that was helpful. Let me know if you have any questions.